In this presentation we are going to look at anagrams as permutations. So this is all about using permutation theory to look at how many ways we can rearrange the letters in words. So how many anagrams, permutations of the letters, are there for the following words? Answer: permute, anagram, and little. Well, let's look at the first one there. So I have given three examples of permutations of the letters: ASN, WRE, SAN, ERW, and so on. Now, since answer has 6 distinct letters, they're all different, the number of permutations is as follows. 6 factorial, and that's equal to 6 times 5 times 4 times 3 times 2 times 1, that is 720. Now, if you're not familiar with factorials, which is that little exclamation symbol there, I suggest having a bit of revision of that first before you continue. So, moving on, what we're going to look at now is the word permute. There are 7 letters, but only 6 distinct letters. We have 2 E's there. Now, there are 7 factorial ways to rearrange the 7 letters, but as we can sort of see here in this couple of examples I've given, interchanging the 2 E's does not result in a new permutation. It does not result in a new word, essentially. What we would have there is 2 identical anagrams. So I have them color coded here. I have a red E and a blue E. And what happens if we swap? Really nothing, we get the same word. It's just the letters are just swapped, but really we get the same word. Mute pair, that's not a word, but it's just an anagram. Again, what happens if we swap over the E's? It doesn't change anything. So for each anagram, there is a sort of twin. There's an identical anagram to it. So we have twice as many as we need, which is to say. So essentially what we're going to do here is divide the total number of permutations by the number of copies we have. So it's actually, the answer is half of 7 factorial. 7 factorial is 5040. So the number of anagrams of the word permute is 2520. And that cuts out all the copies. So that is part 2. Now what we're going to do is look at part 3. Now there are 7 letters in the word anagram, but there are 3 A's. So this is very similar to the last problem. From before, we have 7 factorial ways to arrange 7 letters. But how many, let's just look at the word anagram itself. How many copies of the word anagram do we get if we swap around the A's? There are actually 6 there, okay? So there, all we've done, I have a red A, a blue A, and a purple A. I just moved them around. Those are 6 different arrangements, but really they're all spelling the same word. So we got 6 copies of the same permutation. So what we're going to do here is, what we do in this case is we divide 7 factorial by 3 factorial to account for all the identical anagrams. So it's the number of copies of the same word letter. The factorial of that is what we divide by. So it's 7 factorial divided by 3 factorial. That is 5040 divided by 6. So there are 840 unique anagrams of the word anagram. Okay? Now, just going back to part 2 again for a second, the correct answer of part 2 was 7 factorial divided by 2 factorial. Just to be clear about that. It doesn't change the answer, but it sort of sets out the rule of thumb a bit clearer as to what we do. So it's actually 2 factorial we divide by, which just happens to be equal to 2 for that particular case. Alright, the last one is the word little. There are 6 letters, and there are 2 T's and 2 L's. Now, there are 6 factorial ways to arrange 6 letters, but again, what we do is divide by 2 factorial times 2 factorial. This is to account for the 2 L's, and this is to account for the 2 T's. So it's 720 divided by 4, And the answer there is 180. So that's it. That ends our presentation, and thank you.